In this video, we will be solving this question from Leetcode, remove duplicates from sorted list second. Given the head of a sorted linked list, delete all the nodes that have duplicate numbers and leaving only distinct numbers from the original list. Return the linked list sorted as well. Okay, so the question basically says that you have given a linked list 2, 3, 3, then let's say 5, then 6, 6, and then 7, and it's null. So the question basically says that you have given a linked list and you need to remove all of the duplicates. Okay, so we can see that these two numbers are duplicate, and in here these two numbers are duplicate. So when I'm going to remove these numbers, my linked list will gonna look like this: 2, 5, 7, and null. And this is what I have to do. Okay, I have this given and I have to convert this into this after removing these duplicates. Okay, in this specific question, as this is the second part, you need to delete the original also. For example, this 3 have a duplicate here, right? So you delete this. Okay, then you have to delete the 3 also, because it said this thing that leaving only distinct numbers from the original list. Okay, if any number in the list have a duplicate, that means that number should also be deleted. 3 have a duplicate, that means this and this both will gonna get deleted. The 6 have a duplicate, 6 and this 6 also should get deleted. And this is all we have to do. So let's see how we're gonna do this. So this is our required linked list. Okay, so if I want to remove these duplicates, what I can do is that I can take, let's say, a pointer here, and I can take a pointer here. Okay, now I'm going to compare the value of these two nodes. As I know that these two nodes are having a different value, so I'm just simply going to move these pointers one step ahead. Okay, so this pointer will going to come here and this pointer will going to come here. So we can remove these two, again move it one step. Now I can see that these two numbers became equal. So like these two nodes have a same value. That means this node have a duplicate. As soon as you finds out this thing to the next, this is the next pointer, and this is having the same value as this previous pointer, that means they have duplicate, and you need to delete both of this. Okay, so to delete both of this, what you can do that you can take this 2 and you can attach this 2 simply to 5, and these both will gonna get removed from here automatically. What I actually mean here that you can see here that this 2 is pointing to 3. Okay, what if I make my 2 point to this 5? So cannot I write this thing that 2's next, right now it's 3. What if I make 2's next 5? After this 2 will gonna straight point to 5, and these two nodes will gonna get removed from here automatically because they lost the connection. 2 lost the connection to these two nodes, so you cannot see them in the linked list anymore. So this will gonna look something like this. Okay, so that's how we're gonna do it. This is the whole code. Okay, this is the whole logic. Okay, now as we remove these, that means that my pointer should compare this value and this value. So after this 5, my linked list will going to be remain the same. So that means that I can remove all of this. So 2 is straight pointing to 5, and then you have 6, 6, and then 7, and then it's null. So now I have to check for this 5 and 6. So basically I can put my pointers here. Now my values in these two nodes are different. That means they cannot be a duplicate. That means I have to move these pointers one step ahead. Okay, now I'm gonna check for 6. Okay, so I'm gonna move these pointers ahead. So as I move my pointers ahead, I can see that these two values are same. That means these two nodes have the same value, which basically implies that this node have a duplicate. That means that this node and the another node should get also deleted. So as we did earlier, that we know this is the 5. So what if I attach the 5 to the 7 straight away? So right now this 5 is pointing to 6. I can point this to 7. Okay, so I know this thing that my 5's next is 6 right now. If I want to remove these from here, I have to straight point this 5 to 7. For that, I can write 5's next, make 5's next equals to 7. So now this 5 will gonna straight point to the 7 and it will gonna look like this. 2, 5, and then 7. Now my pointer should come at 7. So I'm gonna put my pointer here and one pointer here. So I can see this thing that one of my pointers became null. Like these two pointers were here. Okay, I compared these. Now these two nodes removed from here. That means this pointer should jump here. Like this pointer should jump here and then here, and this pointer should straight away jump here, so that I can compare that is 7 have some duplicates or not. But I found out that my next pointer is pointing to null. That means that 7 does not have any duplicates and it's the end of the list. Okay, so what if you have more than 2 duplicates? Right now we saw that we have only 2 duplicates, right? What if you have more than 2? How are you going to do that also? So we're going to see that. So now I'm going to build up a linked list which will be having more than 2 duplicates. So let's say this is 2, then 3, 3, and then 4, then 5, 5, 5, 6, 6, 7, and then null. So let's say this is our linked list and I need to remove the duplicate. So I can see this is a duplicate. These 3 are the duplicates, these 2 are the duplicates, and I just need to remove all of them, and I have to convert my linked list to simply this. I only have to return those nodes which does not have any duplicate. This 3 was having, so we remove these and this. Okay. Now I have more than 2 duplicates, so I'm going to see that how I'm going to do that. So I'm going to use the same logic again. That logic works for everything. So my logic says that you take 2 pointers and point them. Okay, I'm gonna point them here and then here. Okay, now these 2 nodes is having a different value. You can see that 2 is not equals to 3. When you don't find values equal, you have to move these pointers ahead. Okay, one step ahead. Right now you check this thing that is 2 have a duplicate or not, because this list is in ascending order. So 2 always will be having a duplicate just after it, not somewhere here. Okay, that's the benefit that this list is actually ascending. Okay, so that's why we have to check the next one, that are you my duplicate or not. So that's why we are checking with these 2 pointers. So as soon as we find out that these 2 are not equal, that means that this 2 doesn't have any duplicate, then I'm going to check for 3. That means this pointer should point here and this pointer should point here. So I'm going to remove them. I'm going to put it here. Then I'm going to check that are you my duplicate? So this 3 and these 2 values are equal. That means that this pointer got is duplicate. That means I need to remove both of these. Okay, now the thing that I was doing, that I was connecting this node to this node, right? So basically I need a pointer here also so that I can connect. Right now I don't have any pointer here, so how I'm gonna connect this to this? Obviously, so I need to have a pointer here so that I can take that pointer and I can point the next of this pointer to the next of this. Okay, so it's getting too much confusion. So what we can do, that we can just name these pointers, right? So we can call this as a previous pointer, and we are comparing our data of the nodes with these 2 pointers, this and this one. So we're gonna write their name a little similar. So let's say it's current 1 and it's current 2. Okay, current 1 and current 2 we're gonna compare values, and previous pointer will gonna help us attaching the node to the after of this current 2. Okay, so I find out this thing that these 2 nodes are equal. Okay, if these 2 nodes are equal, there is a chance that maybe this 3 is having more duplicates ahead? Okay, so I'm gonna leave my previous pointer right here, and I'm gonna check that do you guys have more duplicates ahead? Okay, so I'm gonna rub these current 1 and current 2, and I'm gonna simply point my current 1 here and then current 2 here. Now this current 1 will gonna check that are are you current to my duplicate. If we're gonna tell, okay, no, the value is not equal, that means that my duplicate ends here. Okay, starting was here and ends here. That means these are the only 2 nodes which was my duplicate, because I haven't found that current 2 got any duplicate after that. So basically I can write this thing that previous next is equals to current 2, because I need to connect this previous to this current 2 so that I can remove all of this, right? Since I had connected my previous next to my current 2, I can simply write that 2 is connected to 4 directly, and my current 2 is pointing here. Okay, so now I can remove this for now, and my previous will going to be here. Now my rest of the linked list will going to be exactly the same. 5 will going to be here, then 5, then 5, then 6, then 6, then 7, and then null. Okay, so my linked list is exactly the same. My previous pointer is still pointing to 2 as it was before, but now my current 1, current 2 pointers are destroyed, you can say. Okay, now I need to point my current 1 and current 2 again somewhere. Okay, we know this thing that we compared our 3 to 4. Now I need to compare my 4 to 5, because I need to check for duplicates of 4 also. So I need to check with the front node. So to do that, I can simply make my previous next. This is the next of my previous now. I can make this as my current 1, and previous next will going to be my current 2 for the purpose of comparison. So if you want to write this thing into the code, you can write current 1 is equals to previous next, and my current 2 is going to be equals to previous next. Okay, now I'm going to compare this current 1 value with this current 2. As they are not equal, that means that 4 does not have any duplicate, and I'm going to move these pointers ahead. So after moving my pointers ahead, I can make this as current 1, and now this is going to be my current 2. Okay, now I need to move my previous also. Why I need to move my previous? Because I need to connect. As soon as you find out this thing that the nodes are not equal like the way they are here, you can simply move your previous pointer ahead also. Okay, because for example, if this 5 have duplicates, which it have, you have to connect this 4 to this 6. So if you don't have previous here, you will not gonna be able to do that. So you always need to take care of previous also. Then you need to move this previous ahead. I'm gonna remove this, and I'm gonna move it ahead. Okay, now I got here. Now I'm gonna compare current 1 and current 2. They are equal. If they are equal, don't move the previous, just move the current 1 and current 2 to check this thing. Do 5 have more duplicates or not? You know this thing that we are comparing this current 1 to current 2, because the duplicates will always going to be just ahead of it. So I can simply move only my current 1 and current 2. So I'm going to put my current 1 here, and then I'm going to put my current 2 here. Now I'm going to check that are these two values are equal. Yes, they are equal. If they are equal, then definitely move ahead. Check that are there more values which are equal. So I'm going to move my current 1 and current 2 ahead, and it will gonna look like this. Now current 1 will gonna come here, and my current 2 will gonna come here. Now I'm going to check again current 1, current 2. Now I got this thing that my current 1 is not equals to my current 2. That means my duplicacy ends here. That means these were the only 3 nodes which were having the duplicates. Now you need to do the same thing. You need to connect this previous to this current 2 like the way I did here. you can see this thing that these two things you have to do every time. Okay, so I'm gonna connect this previous to this 6, and after connecting my previous to 6, it will gonna look like, so my 2 is pointing to 4, and then my 4 is pointing straight to 6 because I have to connect my previous next to my current. Okay, this is the previous and this is the current next. These are the duplicates. Okay, then when I do this thing, I have to declare my current 1 and current 2 pointers ahead, because when I did this thing, I know this thing that my current 2 pointer, is here. Okay, this is current 2 pointer, but my current 1 pointer is missing. So to resolve this issue, we basically just declare them again with the help of previous. Okay, so my previous, I know this thing that my previous is pointing here, so I can put it here. And now I can remove this current 2 from here because I'm declaring it again using these. So I can see this thing that my current 1 is previous next. So previous next, this is current 1. This is current 1 now. So to check for the duplicates of 6, I have to go for current 2 also. So I'm going to complete my linked list. After this, it's going to be exactly the same. So 6 will be here, and then 7, and then null. Okay. So my current 2 is previous next next. So this is the next of previous, and this is the next next of previous. So I'm going to point my current 2 here. Okay. Now I'm going to check that are current 1 and current 2 equal or not. Yes, they are equal. If they are equal, I'm not going to move the previous. Instead, I'm only going to move this current 1 and current 2. Okay. So I'm going to move my current 1 and current 2 ahead, and it will gonna come here and then here. Now I got to know that my current 1 and current 2 are not equal. That means these two were the only duplicates. Now I can simply connect my previous next to my current 2 using this line, and it will gonna look like this. My 2 is here, then my 4, and then my 6. Sorry, not 6. 6 is deleted now. And now we have 7. Previous next equals to current 2 and is pointing to null. Okay, so this is my previous. I got my previous here. Now I have to check that do this 7 have duplicates or not. If I need to check this 7 have duplicates here or not, that means I need to declare my current 1 pointer here, which I did because I know this is my previous and this is the previous next. So previous next is current 1 as we had saw, and previous next next is my current 2. So my current 2 is going to be pointing to the null. Now one of these, like see, we in null we don't have any value. It's an end of the list. So we cannot compare the value of current 1 and current 2. We cannot compare these two values. So we need to overcheck for this condition even before comparing the value. Is your current 2 next? Is your current 2 is null or not? Now I know this thing that my current 2 is null. That means that the current 1 does not have any duplicate and it's the last node. After this, I can simply return my list because this is going to be my answer. I can simply, my head was exactly here. I know this thing my head was initially here because my head is not deleted. So I can simply return in the end head. Okay. So the condition that I'm saying that you need to check this is current 2 equal or not. Before you compare these two values, just make sure that this current 2 is null or not. So to write that condition, you can simply write current 2 shouldn't be null. Okay, we will see this later, that where this is gonna come in use, okay, in the code. So right now our main thing is done, but there's just one small thing. The small thing is that we were having this linked list, right? And this was our head here. So our head was pointing here. In the end, we have to return the head of the linked list. Okay. And we are deleting all those nodes which have duplicates. What if this 2 also have duplicates? Then what are you gonna do? Let's say these two have duplicates. That means the two will going to be here. Okay, that means if my linked list is, that means my linked list will gonna start from here. Then that means this is going to be my head. So how I'm gonna do this? Because I need my previous pointer so that I can connect my this node to this node. For example, if I'm deleting these two nodes, my head is deleted first. Okay, if my head is deleted, I'm not gonna be able to return my list. So to avoid this thing, what I can do initially, if I remove all of this, initially I can just create a dummy node here. I can simply create a dummy node here. Let's say the dummy node is 0 and it's pointing to the head of the list. Okay, and instead of pointing my pointer on the head here, I can simply make my previous pointer point to my dummy node. What is the benefit of this? For example, these two nodes, like the head is having duplicates. If the head is having duplicates, that means I need to delete both of these nodes, right? If I'm going to delete both of these, my head will gonna get deleted. To avoid head getting deleted, we do gonna delete these two nodes. Okay, so firstly, if I want to delete these two nodes, then that means previous next should be my current one, previous next should be my current 2, and I'm gonna compare the value. The value is exactly the same. Then I'm gonna keep my previous here and I'm gonna move my current 1 and current 2 one step ahead. So it will gonna look like this now. So my current 1 will be pointing here and my current 2 will be pointing here. Then I'm gonna compare the value. 2 is not equals to 3. Okay, so if 2 is not equals to 3, that means my duplicates ends. So these are the only two duplicates. Now I can connect my previous to my current 2 by using this line, previous next is current 2. Okay, so I can simply rub these. My head is deleted now and my previous will gonna straight point to this 3. Okay, now I'm gonna do the same thing. My previous next will, this is the previous, this is gonna be the previous next. Now this will gonna become current 1, then this will gonna become current 2, this will gonna compare, then it will gonna move ahead. We saw this thing here. After this we know how we delete this, right? Only problem was with the head. Okay, so right now my previous is pointing to this 3. After that we know this thing that this is having duplicates, so somehow this will gonna get deleted. Then my previous will gonna point straight to this 4. Then this my 5 will gonna get deleted from here. This is having duplicates. We saw this thing earlier, right? Then I'm gonna point this here. Now my 6 will gonna have duplicates, will gonna get deleted. Now my this 4 will be pointing here, and as I'm connecting my 4 to 7, that means my previous was pointing to this 4. My previous should be here, and then my previous gonna get. So I know this thing that this is my dummy node. This is my dummy node. And this is the whole list that I need to return 4, 7. This is the whole list. Okay. 4, 7 is what I have to return. That means, how can I return this? What if I return the dummies next? I can simply return, this is the dummy node, and I can simply return the dummies next, which is this 4. If I return this 4, that means after 4, whatever the list gonna be, it will gonna get returned. I can also do one thing. I can save this dummies next into a different pointer. For example, I can simply write that list node star temp is equals to dummy, and then I can delete the dummy and I can return the temp. So what I did here, I basically, sorry, this is going to be dummies next. So I know this thing that this is the dummies next. This is the dummies next. So dummies next I made as temp. Then I deleted the dummy from here and I returned this temp instead. This is the temp. So when I'm going to return the temp, in the answer, it will going to return this 4, 7, and then null, because this is my temp, which is acting as head now. So this is going to be my answer. So this was the whole logic for solving this question. So let's write code for this. Okay. Okay, the first thing I'm doing in the code is basically that I have to declare a dummy node. I have to create a dummy node. Okay, so to create a dummy node, we're gonna write list node star dummy equals to new list node, and we're gonna put a 0 value inside. Then I have to connect this dummy node to my list. So to connect my dummy node, I'm simply gonna write dummies next is head. That means point the dummies next as head. So we know this thing that our dummy was here. This was our dummy here, and I need to point this dummy to my head. Initially my head was this 2, right? So if I create this dummy node, I can point this here. This is the dummy. That's what I write. Dummies next is head. So I connected my dummy node to my list. After that, I have to declare a previous pointer which will be pointing to my dummy. So list node star previous pointer which is pointing to my dummy node. Right. After this, I have to traverse the list by using this previous and current one and current 2 pointers. So as I know this thing that my current one and current 2 pointers I was declaring again after I found out that the list after I found out that I have connected successfully this previous next as current 2. Right. So if I able to connect this previous next and current 2, that means that it was having some duplicates between them, and I have deleted all of them. I've connected my previous straight to the current 2. Then I can declare these again, and it will gonna work out for the next purpose. So I'm gonna create a while loop as I'm traversing, and in this while loop I'm gonna write previous next shouldn't be null and end previous next shouldn't be null. Now why I did this? Okay, I'm basically checking that are my current 1 and current 2 values are available or not. As I told you here that my current 1 and current 2 values should be present for the purpose of check, because I am checking that is the current 1 value is equal or not equals to current 2. So this is basically my current 1 and this is basically my current 2. Both of these should be present. Then only I should move ahead for the purpose of checking the duplicate. If only this is present, that means that this value doesn't have any duplicate. If both are present, then only I can say that if they are equal, that means they have duplicate. So that's why I am running the while loop. If any of them becomes null, then definitely I don't have any duplicate. If firstly this become null, that means that my list is ended now. If this becomes null, that means that I have my current 1, but it's the last node, so it does not have any duplicate. Okay. Second thing that I'm doing, I'm declaring my current 1 and current 2 pointer inside. My current 1 is basically my previous next, and my current 2 is basically my previous next. Okay. Then I will be checking that is current 1 and current 2 equal or not. If current 1 is not so we are checking the values, so basically we have to write that if the current 1 value is not equals to current 2's value, if they are not equal, so like we saw this thing, if they are not equal, then move ahead, no problem. Then you can simply write here that move the previous ahead. Previous equals to previous next. Why we are not moving our current 1 and current 2? Current 1 and current 2 are based on my previous. So if I'm moving my previous ahead, that means I'm moving my current 1 and current 2 automatically ahead. because this is previous next, this is previous next. Okay, let's see an example for this. Let's say you have a linked list right here, 2, 3, 4, and null. Okay, this does not have any duplicates, right? And this is our dummy node 0. My previous pointer is pointing here. On my previous next will be going to be my current one. My previous next will be going to be my current 2. So I can basically see this thing that my current 1 and current 2 are not equal. That means I need to move ahead. That means this 2 does not have any duplicate. I have to check for 3 now. So I have to move these ahead. I can do one thing, that I can make that like currents 1 equals to currents 1 next, and then currents 2 equals to currents 2 next. Instead of doing this, what we are actually doing here, we are simply moving our previous ahead. Only the previous ahead. And when this will gonna check the loop again, it will gonna go here again. After this, it will gonna go here again, and it will gonna set previous next as current 1 and previous next as next as current 2. So my current 1 will gonna point here, my current 2 will gonna point here. It's like the same thing. Current 1 came here and current 2 came here. Now I'm gonna check for this. So this what it means. Okay, it's like a shortcut. Now what I have to do, that this is for the purpose if they are not equal. What if they are equal? That's our main case. Else if your current 1 value is equal to current 2 value, that means the node have duplicates. If the node have duplicates, I know this thing, that I don't have to move my previous. Instead, I have to move only my current 1 and current 2, so that I can check that are there more duplicates or not. So for the purpose of moving only my current 1 and current 2, I can simply create another while loop. And in this while loop, I can write this thing, that you move this while loop until you see duplicates. As soon as you see this, like this will gonna enter here, like you find out that current 1 and current 2 are equal, then you have to check that how many of the ahead of this nodes are equal. Okay, so this thing will gonna do this while loop, where it will gonna run until it finds they are not equal. Okay, so even before going to this step, as I told you this thing, that what if one of them became null? One of them became null. Like for example, if current 1 is there and the current 2 is null, so you have to precautious that you have to check this thing, that is the current 2 is null or not, because if you're gonna check the value of null's value, it will gonna give you an error. So even before checking this, just make sure that your current 2 is not null. In the while, I can simply write current 2 is not equals to null, and then this. If this current 2 became null, if this became null, that means it will gonna be false. And if one input is false in the end one, that means the whole input will be false. Okay, then the while loop will be false and it will not gonna run anything inside. So this is a must check. Now I know this thing, that I have to run this while loop until I find duplicates. So I simply have to move my current 1 and current 2 ahead to check for more duplicates. My current 1 will gonna move ahead, my current 2 will also gonna move ahead, right? And it will gonna run until I finds out that they are unequal. So let's see what I actually mean here. So now we're gonna create a linked list, 2, 3, 3, then 4, and then null. Let's say my previous is pointing here, then my current 1 is here, my current 2 is here. Let's take this also 3. This is 3. Okay, now as I can see this thing, that my current 1 and current 2 are equal. So my current 1, this condition will gonna be true, current 1 and current 2 are equal. Now I'm gonna run this while loop. So my current 1, current 2 are equal. That means I have to move my current 1 ahead and current 2 ahead also for checking are there more duplicates or not. So my current 1 will gonna come here and my current 2 will also gonna come here. This loop will gonna run again. It will gonna check again, is current 1 current 2 equal? Yes, they are equal. That means this will gonna execute, and this will gonna come here again. So my current 1 will gonna move here, and my current 2 will gonna move here. Now I'm gonna check again. I'm gonna go into the loop. Now I know this thing that now my current 2 became null. Current 2, it should only run when current 2 is not equals to null. My current 2 became null. That means this whole thing will gonna become false, and this will never gonna execute. Now what I can do, I can simply make my previous next as my current 2. Okay, after the loop I can simply write my previous next is current 2. So I can rub all of this, and my previous next became null. So this is going to be our final linked list. So after this loop, I simply have to just write one line that make the previous next as current 2. It basically means that there's no more duplicates, just connect them now. I'm gonna close this now. Okay, now it will gonna run from here to here, this one while loop. This is the main while loop again. It will gonna check that after this, it will gonna check again that do you have previous next and previous next, so that I can check for more duplicates. Okay, then it will gonna set these current 1 current 2 values. Then it will gonna check are they equal or not, and then this deletion gonna happen, and then you simply have to connect, then check again. So this is the whole code. In the end, I told you this thing that you simply have to delete the dummy node and return that. So for the purpose of deleting the dummy node, write list node star temp is the dummy's next, and delete then dummy, and simply return the temp. And you know one thing, that when I'm going inside of my loop by checking these two things, I'm actually doing a very good thing for the edge cases. Like, let's say you have a list of just one node. You have only one node in the list. If there's only one node, doesn't matter what is the node, definitely does not have any duplicates. That means I still be creating my dummy node, because I'm doing that before the while loop. So I'm creating this dummy node, and my previous is pointing here. Now in the loop, it will gonna check that previous next is not shouldn't be equals to null. This is the previous, and next of this is not null, so it's true. That's good. Now it will gonna check that previous next is not null, but previous next is null. That means current 2 will going to be null. That means we cannot compare this current 2 value. Okay, that basically means that this loop will never gonna execute. None of the things will gonna execute for this purpose. After that, you simply gonna delete this node and gonna return this list as it is. So let's see on Leetcode, and we're gonna put this code there, and let's see if it runs or not. So this is our question on Leetcode, remove duplicates from sorted list. So we're gonna write the code for this. So the first thing that we were doing, we were creating a dummy node at the front. So list node dummy is equals to new list node, and 0 inside we're gonna put. Now we're gonna attach our dummies next to our head. It will gonna attach our dummy node to our linked list. Second thing that we were doing is we were declaring a previous pointer which will be pointing to the dummy instead. Okay, then after that, we were creating our while loop. In the while loop, we were checking that is the current 1 and current 2 are available or not for me to check. And previous next is not equals to null. Inside of this, I just have to declare my current 1 and current 2. So this is going to be equals to my previous next, and my current 2 will going to be my previous next. After this, I'm running here, I'm checking the values that are they equal or not equal. So the firstly that if they are unequal is not equals to the current 2 value. If they're not equal, then move only the previous. Current 1, current 2 are dependent on previous, so they will gonna move automatically, as I told you. After this, I have to write an else condition. What if they are equal? If they are equal, current 1 well value is equals to the current 2 value. If they are equal, check that is there, if they are equal at first, then check that are their more nodes equal. So for that, I'm gonna use a while loop inside of this, and then I'm gonna check that is current 1, run this while loop until you finds out that current 1 is not no more equals to current 2. It basically implies that there are no more duplicates. So the first thing I need to check that current 2 shouldn't be null. If it is null, it's not a good sign then. So in this while loop, I simply just have to move ahead to check for nodes. Current 1 next, and then I have to do current 2 equals to current 2's next. Okay, and this is going to be the while loop. After this while loop will gonna end, as then that means that it find out this thing that currents after this while loop will gonna end. That means that my current 1 is no more equals to current 2. That means I need just to make my previous next connect to my current 2 so that it can skip all of those duplicate nodes. So this is how going to be our whole while loop. In the end, I simply gonna delete my node, dummy node. So list node star dummy is equals to, sorry, we have to take a temp pointer which will be pointing to the dummies next, and after that I can simply delete my dummy node and I can return temp. Now it's behaving as a new head. Okay, what if your linked list is totally empty? If linked list is empty, that means that the previous next is null. Previous next is null. If it is null, that means this loop will never gonna execute. It will gonna delete the dummy node and it will gonna return null, because dummy's next will be null then. Okay, if the head is null, that means dummy's next is null. So let's see if our code runs or not. So we just did a mistake here. Current 1 is equals to previous next. This current 2 is equals to previous next. So I forgot to write previous here. And we had to declare these pointers. We haven't declared these pointers also. So we have to declare these pointers here. List node star. These are the two new pointers that I have to declare every time. So we can see our code is accepted. This 3 got removed, this 4 got removed, and it gave you 1 to 5. In this case, you can see our head is having 3 duplicates, so head is removed, and we got this. Now we're gonna submit this. So we can see our code is accepted and our 166 test cases passed, and it took 0 milliseconds of time. So this was our code, and hope you like it and hope you understood. I'll see you in the next one.